Alright, previously we have learned a bit about pressure in liquids. So based on what we have learned, we have seen that the formula for pressure in liquid is equals to P equals to H rho G, where H is the height, rho is the density, and we got G is the gravitational acceleration. So, and based on this formula, we obtain that the units for pressure is first is either Pascal, and then we also get Newton per meter squared, and also we can get kilogram per meter per second squared. These are the three units that we have seen in our previous class. So let's recall. Let's say you have a tall jar here, and this jar is filled with water. And underneath the jar is a point. Let's say it's point A. So if question asks you to find the pressure of water at point A, so we return back to the formula P equals to H rho G. We get the H is 3 cm, but don't forget to convert to meter, divide by 100, and then rho, the density of water. Let's say the density of water here is 1000. Then substitute here. And also the gravitational acceleration, we put 10. So based on this simple formula, we can get that the total pressure, the pressure of water at point A is equals to 300 Pascal. Let's say the question asks, what is the total pressure at point A? So when the question said total pressure, there's something you need to remember, that since we are living on Earth, everything is affected by the atmosphere, and therefore we have another constant we say as atmospheric pressure. So to calculate the total pressure at point A, we have to add all the pressure in liquid plus pressure of the atmosphere. So what is the pressure of the atmosphere? So generally speaking, we know that the pressure of the atmosphere is given by the value of about 100,000 Pascal or 100 kilopascal. So based on the information, we can obtain that the total pressure at point A is equals to 300 plus 100,000 Pascal, which is the pressure of the atmosphere. Therefore, you get the answer of the total pressure. Alright? So, let's see the example. Here, in example 1, figure 2.7 shows a fish is at a depth of 1.5 meter. 1.5 meter. in an aquarium, given that the density of water in the aquarium is 1050 and atmospheric pressure is 100 kPa. You also get the gravitational acceleration here. So let's see at question A. What is the pressure experienced by the fish caused by the water around it? It means the pressure in liquid. So in pressure in liquid, we know that the formula is given by P is equals to H rho G. So by using the formula we know, P equal to H rho G, you get that the pressure in liquid acting on the fish, H is 1.5. So you substitute 1.5. And then what about the density? Density is given by 1050. Multiply with gravitational acceleration 9.81. So by multiplying all this, you get the answer, the pressure acting on the fish by the liquid. So it's time to press your calculator. So you get the pressure exerted by the liquid is 15450.75 Pascal. Okay, now let's see at question B. It says to calculate the actual pressure acting on the fish. When the question said about actual pressure, we know that there's one pressure that keeps acting on us, and that is the atmospheric pressure. Okay, so what we have to do is the actual pressure or the total pressure is equals to the pressure in liquid plus pressure of the atmosphere. So we just simply add all the pressure. So based on this, get the answer 115450.75 Pascal. Alright then. Next, let's see for example 2. So figure 2.8 shows U-tube filled with water and olive oil. Okay, when they say it's filled with water and olive oil, it means that these two liquids do not mix. Okay, that is why you can see that on the figure here, even though we know that water is denser than oil, but the water is on top of it. Why? Because they don't mix. And because the amount of the oil is greater than water. That's why the oil is pushing the water upwards. Why? How come the oil push the water upwards? Because they do not mix. Okay, it's water and oil. Now let's see. The question asks to calculate the density of the olive oil. So if I ask you to choose one position where the pressure is the same between the water and the oil, it means you have to make a straight line. Let's say here, this straight line, the pressure here is equals to the pressure here. Or if I put here, the pressure here is equals to the pressure here. Or let's say if I make another line here, it means the pressure here is equals to the pressure here. We know that the formula for pressure is H rho G for pressure in liquid. So the lowest point that we know between the water and the olive oil, that we have the height is here, which means we can simply take that the pressure here is equals to the pressure here. Since we know that pressure equals to H rho G, so that means we can use the formula to equate that the pressure at this point A and this point B. Okay, so that means we can make that pressure at point A is equals to pressure at point B. Based on this formula, we substitute the equation HA rho A G is equals to HB rho B and G. Actually, there's another thing. It's a pressure of the atmosphere. But since the pressure of the atmosphere is the same for both cases, that is why we simply cut it out. So we don't take it into account because it's the same. Now let's see. Here also we have G and G. Therefore we can cancel out each other. And lastly, we only get HA rho A equals to HB rho B. So the question asks to calculate the density of the olive oil. So the question asks to find rho B. Can we find it? So simply substitute or rearrange the equation. Rho B is equals to HA rho A divided by HB. So we plug in the value. HA we get 15. What about rho A? Rho A is 1000.
Sorry, I don't know the answer to that one.
And then what about HB? HB is 16.5. So you simply calculate the answer using calculator. And finally you get the answer 909.09. What about the unit? Since it's density, so it must be in SI unit also, kg per meter cube. So here's a question. Do we need to change the unit for height into SI unit? Because here is in cm. Here also is in cm. So the answer is, in this case, we don't need to, because we are comparing or we are dividing two things of the same unit. That means here is cm, here is also cm. So cm divided by cm, the unit cancel out each other. So you can use the same unit. Okay? That's the answer. Any question? It's not that you can ask. So let's see next. So here are the applications of pressure in liquids in our lives. So let's see the first picture. The first picture is our water tank. Why is it put at the top of the house? Because it can flow with higher pressure. Okay, because it depends on height. So the higher the water tank, the higher the pressure we can get. So that is why. Okay. And then what about B? What about the second picture? So we know that we want this liquid to flow into our bloodstream. So the only way that we can make the liquid get into our bloodstream is by putting it at a higher position than our body. How come? Because this difference in height. Okay, actually there's an atmospheric pressure acting on this, but since we are also living in Earth, whereby the atmospheric pressure constantly acts upon us. That means we also exert the same amount of pressure from our body to the atmosphere. That means, let's say the atmospheric pressure acts upon us. We also have our own pressure that equals to the atmospheric pressure. So that is why this thing need to be of greater pressure. It actually equals to pressure of the atmospheric, pressure of the ATM, plus the pressure of the liquid based on the height. Okay, that is why. And then next, the construction of a dam. Let's see. So the wall of the dam is getting thicker as it goes downwards. Why? Because we know that pressure equals to H rho G. So here it has greater height. So it means greater height also gives greater pressure. So to protect this area from any damage caused by high pressure of water, that is why the wall of the dam need to be built at a thicker thickness, which means it's also stronger. And let's see that the water in, why do we make the control door is at here? Why is it not somewhere above? Same reason, because of the greater height or greater depth increases pressure. That is why the higher the pressure will cause the turbine to rotate at higher speed, therefore generating enough electricity. Okay. Next, using the siphon. So we know that the siphon is used to transfer water from a higher region to a lower region. How does this thing works? Here's how. So first thing first, you fill the tube with water. Okay? Then you put it here like this. What happens is, initially you close the end of the siphon, but then the moment you release your finger, gravitational acceleration will start pulling the water downward. Okay, when water is being pulled downward, it creates a vacuum here. This vacuum causes this region to have lower pressure. Due to the lower pressure, it gets lower as the water is being flown out through D. What happens is the atmospheric pressure that keeps on acting on every surface will push the water. So in addition to the atmospheric pressure and also the pressure in liquid, the greater pressure will move the water upwards due to the difference in pressure caused by the vacuum of the region here. That is why, as long as you don't move the end of this D higher than this level, then the water will keep flowing until the aquarium or the tube or this region is completely drained of water. Okay, that is how a siphon works. Any question? So now let's see. We've already learned pressure in liquid. Let's see here. Liquid can be transferred out continuously from a reservoir for a period of time without the use of electrical power. What are the factors that affect the rate of the transfer of liquid using siphon? So what are the factors? So actually the factors came back to the original thing that we have learned, that is pressure. So what are the pressures? What are the formula for pressure in liquid? So H rho G. So these are all the factors that affect the rate of transfer of liquid. Okay, ATM does not affect because it is same everywhere. So back to basic, H rho G, these are all the factors that affect the rate of transfer liquid of a siphon. Now let's see formative practice 2.1. This is your homework. Complete this by tomorrow. And when I say by tomorrow, it means by Wednesday, 24th of February. I'll create the assignment. You just need to submit it through Google, through Microsoft Teams, okay? I believe you can answer all this question. It's so simple. That is all for today. So I'll see you in our next class. Goodbye.